Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My course is going to help the students who are preparing for CSIR-NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam exam and other exams related to physics. And guys, my courses are absolutely free of charges, and anyone can watch it. And my courses will help the students to crack the examinations related to physical science. Okay, so this is the lecture number 4 of quantum mechanics PYQ, which we are going to solve today. Okay, so before that, I would like to thank you everyone who subscribed my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. Okay, so now we are going to start. So we are going to start quantum mechanics PYQs, and it is lecture number 4. Okay, so first question I'm going to start. The first question. Okay, the first question is the component the component along an arbitrary direction arbitrary direction n cap with direction cosines with direction cosines with direction cosines which are nx comma ny comma nz of of the spin of the spin of spin half particle of spin half particle spin half particle is measured is measured. The result is okay, and options are given. Option number A 0, option B plus minus h cut by 2, okay, and Z. Option C is plus minus h cut by 2 nx plus ny plus nz, nx plus ny plus nz, and option number D is plus minus h cut by 2 plus minus h cut by 2. Okay, so this is the question, first question of quantum mechanics PYQ of lecture 4. Okay, so the question is the component along an arbitrary direction n cap with direction cosines nx ny nz of spin, okay, of spin half particle is measured. We can make a diagram so it will be easy to understand. Okay, so we can say this is nx, okay, this is ny cap, okay, and this is nz cap, okay, and this is this is the spin, okay, spin vector S, and this is any arbitrary vector n cap, okay. So what we need to find out, the component along an arbitrary direction, this is the suppose this is the arbitrary direction, okay, component along an arbitrary direction n cap with direction cosines is given nx, ny, nz of the spin, okay, of spin half particle, okay, the particle is spin half, okay, is measured. Now we need to find out the result, okay. So it's very good question. So first we'll write S vector is going to be Sx I cap plus Sy j cap plus Sz k cap, okay. And vector n we can write nx I cap plus ny j cap plus nz k cap, okay. Yes, and now we know because nx, ny, nz are direction cosines, okay. So there is a property for direction cosine, that is if we take if we do mod square, that is n square equal to nx square plus ny square plus nz square is going to be 1. So this is the property, guys, okay. Note down, if direction cosines are given, so their square, their sum of square is 1, that is direction cosines are nx, ny, nz, it means nx square plus ny square plus nz square equal to 1, okay. Okay, so this is the one, and now we know because it's a spin half particle, so value of Sx is going to be, that is 0, 0, 0 and h cut by 2, 0. This is the matrix, okay, for Sx of spin, okay. And Sy is going to be Sy is going to be 0 minus iota h cut by 2 iota h cut by 2 0, right. And Sz is going to be, that is h cut by 2, okay, let me just write it, h cut by 2 0 and 0 minus h cut by 2, right. This value we know, okay, because we know the polymatrices, and similarly we can get, like we can write like this as well, like Sx equal to h cut by 2, then polymatrix, that is 0 1 1 0, okay. Similarly Sy as this, right. This is the polymatrix, because we know Sx equal to h cut by 2 sigma x, okay. So by this we got these values, okay, value of S. Similarly S, because we know the polymatrices, right, sigma x, sigma y, sigma z, okay. Okay, this is the sigma x. Similarly sigma y we can find out, okay, 0 0 minus iota 0, right? Okay, so these are the values of Sx, Sy and Sz. Okay, so now what we are going to do, we will find out n dot s. Okay, n dot vector n dot s, right? So this is going to be, we'll write it nx I cap plus ny j cap plus nz k cap dot sx I cap plus sy j cap plus sz k cap. Okay, now we'll put the value. So this is going to be nx I cap plus ny j cap plus nz k cap, right? And the value of sx, sy we know. So this is going to be 0 h cut by 2 h cut by 2 0. This is sx I cap, right? Plus sy is 0 minus iota h cut by 2 iota h cut by 2 0 j cap plus h cut by 2 0 0 minus h cut by 2. This is the value of sz into k cap. Okay, so this is the value. Now what we are going to do is we'll solve it further. So we know the dot product, right? How we can do dot product? This one, this is dot product. Okay, so it is going to be n dot s is going to be this one. We'll add it, right? So this is going to be nz h cut by 2 and h cut by 2 will take as common, so it is going to be nx minus iota nz, and similarly this is going to be h cut by 2 nx plus iota nz, and this is going to be minus nz h cut by 2. Okay, we'll get this matrix after solving this. Very easy, just we need to do dot product and then add these matrices. Okay, so now so this is the matrix. Okay, now let lambda is the eigenvalue of this matrix. Okay, let lambda is eigenvalue of n dot s spin, right? So eigenvalue, then we know how to find out the eigenvalue, right? Matrix, this is going to be, it means mod n dot s minus lambda equal to 0, right? This we know. So we know the value. This is going to be, this is the matrix. Okay, and we'll do this one, n dot s minus lambda, and lambda I, actually it's lambda I, right? lambda I is identity matrix of 2 cross 2. Okay, lambda I. So we'll put the value, and it's going to be nz h cut by 2, we have written, right, nz h cut by 2 minus lambda. Okay, h cut by 2 nx minus iota ny. This is h cut by 2 nx minus iota ny, iota ny, and this is minus nz h cut by 2 minus lambda. This is 0, right? Because we know we just we have this matrix value and lambda I value we know, right? This identity matrix is 1 0 0 1, and if we say lambda I, will multiply by lambda, so it is going to be lambda 0 0 lambda, right? Lambda I. So we have put this value here, and then we simplify, and we got this value, right? I hope you understood, guys. Okay, so now we'll solve it. That implies this is going to be minus okay. Okay, just let me check it. Let me check the connection first. Is it working? Yes, it's working. Okay, so we'll put the value here. We'll simplify it. It is going to be nz h cut by 2 minus lambda. Okay, into nz h cut by 2 minus lambda. Okay, this will get multiplied, so this will be minus h cut by 2, this is h square h cut by 2. This is going to be like, directly I'm writing h to the power h square upon 4 h square upon 4 into this will get multiplied, right? Nx, this is nx and this is plus, guys. Okay, so this is going to be a plus b, a minus b, a square minus b square, right? So nx square plus ny square. Okay, because iota square is minus 1 minus 1 minus 1 plus 1 ny square. Okay, that is equal to 0. Next page. So it is going to be this is minus, okay. This is minus, okay. We'll further simplify it, so it is going to be minus nz square h cut square upon 4 minus lambda square, okay, minus h cut square upon 4 nx square plus ny square, okay, equal to 0. So here we can take h cut square upon h minus h cut square upon 4 common, okay. So it is going to be, we have taken minus as common, right? So it is going to be nx square plus ny square plus nz square, okay, plus lambda square equal to 0, okay. That implies, because we know, because nx, ny and nz are direction cosines, okay, direction cosines, and I already explained this. The value of nx plus ny, nx square plus ny square plus nz square equal to 1, okay. So then it is going to be minus h cut square upon 4 into 1 plus lambda square equal to 0, right? That implies lambda square equal to h cut square upon 4. That implies value of lambda equal to plus minus h cut by 2, okay, plus minus h cut by 2. This is the answer, guys. So we'll check which option is matching, okay. So option number D is the correct one, okay. Option D, that is plus minus h cut by 2. Plus minus h cut by 2 is the correct option, guys, okay. So this is the one. Okay, so now we are going to solve question number 2. This is the question regarding related to commutator, guys, okay. So easy question. So question number 2 is, the commutator x square p square is, okay. Options are given. Option number A is 2i h cut xp, 2i h cut xp. Option B is 2i h cut xp plus px, xp plus px. Option C is 2i h cut px, 2i h cut px, and option D is 2i h cut xp minus px, okay. So this is what the question is. So we need to find out the commutator x square comma p square, okay. So before solving this question, I will tell you some properties which is used in this question. Okay, so first xp, okay, value of commutator xp is I h cut. Okay, okay, and uh, if it is px, then it is going to be minus I h cut. This is the first one. Okay, one, and second property I'll tell you, that is uh, that is a commutator a comma bc. If you will open it, so it is going to be uh, a into a ac, sorry, this value is going to be this is a into, this is a comma b into c, okay, plus b into ac. Okay, this is the first second property, and this is the third property of commutator is if it is abc. Okay, if you have to find commutation of ab comma c, it is going to be into bc plus ac into b. Okay, so these three properties you should know, and then you can easily solve this question. Okay, so xp, value of xp is I h cut, and similarly how to open commutation abc and abc. Okay, okay, so now we'll solve it. This is x square p square. Okay, so we can write x square p into p, we can write it, right? So then we'll open it by this property abc. It is going to be abc plus bec. Okay, so we'll write this x square p, then p plus uh, p into x square p. Okay, this is the one. Now again we'll write it x into x p outside p plus p x into x comma p. Okay, this also will use this property abc, commutation of abc ab comma c. This is going to be a outside, then bc plus ac outside b. Okay, so again we'll write the value. So this is going to be this one, x comma p, okay, plus xp outside x, and then this is going to be p. Okay, plus similarly p is here. Okay, so this is going to be, we'll use the third property which I have mentioned. Okay, this is going to be xp plus xp into x, right? So we'll solve it. So this is going, and we know value of xp I have already mentioned, this is I h cut. We'll put the value. So this is going to be x I h cut plus xp is I h cut x. This is 1. Okay. I h cut x. Okay. And whole is going to be like p is outside plus p is outside. This is going to be x I h cut plus I h cut x, right? So this is going to be how we will do, like I h cut will take common. Okay, so this is going to be x. This is xp plus xp. Okay, here also will take I h cut common. Okay, complete I h cut common we are going to take from here as well I h cut. So this is going to be px plus px. Okay, so this is going to be the value of x square comma p square is going to be here these will get added, right? 2p 2px 2xp and 2px. So then it is going to be 2 I h cut will be common. It is going to be xp plus px. Okay, this is the answer. That is xp plus px. That is option number B. So we'll go to question. This is option number B is the answer. Okay, this is 2 I h cut xp plus px. Okay, so option B is the correct one. Simple question. Okay, so this is 3.5 marks question which is asked in CSIR-NET. So all these questions are from CSIR-NET and all are PYQs of CSIR-NET. Okay. Okay, so we are going to solve next question. That is question number 3. This is a free particle. A free particle. A free particle described by a plane wave, a plane wave, and moving in positive and moving in the positive z direction undergoes scattering by a potential VR equal to V naught if small r less than equal to capital R, or VR equal to 0 if small r greater equal to capital R. Okay, this is the condition which is given, and if V naught is changed, if V naught is changed to V naught. So we have changed the V naught, right, from V naught to 2 V naught. keeping R fixed. Okay, we have kept R fixed. Okay, keeping R fixed, keeping R fixed. Then the differential scattering cross section, then the differential scattering cross section, differential scattering cross section, differential scattering cross section in one approximation, in one approximation, in one approximation. Okay, in one approximation you need to find. Options are given: increases to 4 times, increases to 4 times, increases to 4 times the original value, the original value, increases to 4 times the original value. Option B is increases to twice, increases to twice, increases to twice the original value, original value. Option C is decreases to half, decreases to half, decreases to half the original value. And option D is decreases to 1/4, decreases to 1/4, 1/4 the original value. Okay, okay. So the question is a free particle. So there is a free particle which is moving. Okay, described by a plane wave. So that particle is described by a plane wave in and moving in positive z direction, and which is moving in positive z direction, undergoes scattering by potential. So that particle goes scattering, and the potential is given. Potential is Vr equal to V naught if small r less equal to r, or Vr equal to 0 if r greater equal to capital R. Okay, that is the given. Now what happened, what is done is, if V naught is changed to V naught, so what we have done is we have increased the potential 2 times. Okay, so if V naught is increased by 2 V naught, keeping R fixed, R is constant. Okay, we have fixed the R. Then we need to then the differential cross section we need to find out in one approximation. So it is going to increase or decrease. The options are given, right? Like first option is increases 4 times the original value. Similarly, increases twice the original value, decreases half the original value, and decreases 1/4 the original value. So that is the question. Okay, so now we are going to solve this very easy question. Okay, so whatever given, we'll write it first. V naught is given. Okay, this is the solution. So V naught equal to given, that is sorry, this is V. So V R equal to given, V which is function of R, that is given. But here it's constant, that does not depending on R. Okay, so V R equal to V naught. Condition is if R less equal to R, or 0 if R greater equal to R. Okay, so this is the given. Okay, so now there is a formula you need to note down, very important formula, so you can easily solve these type of question. Okay, so low energy means at low energy scattering amplitude. Low energy scattering amplitude low energy upon 2 pi h cut square, and then the V naught, that is the potential, into 4 by 3 pi r cube. Okay, this is the one. Okay, so this is very important formula. At low energy, you must note down, that is scattering amplitude at low energy is this. Okay, very important formula, note it down. Okay, so now we know different, so now if we know the scattering amplitude, we can easily find out differential scattering. Okay, so differential scattering, differential scattering, we know that is d sigma 1 upon d omega. Okay, d omega is mod f square, that is f, this one, the scattering amplitude, right, which is function of mod f square. Okay, so f is this one. Okay, this we know, this is also important. Okay, these two formulas you need to note down. Okay, many questions you will be able to solve from these formulas. Okay, okay, so now we can easily find out this one, right? So f1 square, so we can find differential scattering d sigma 1 upon d omega. It is going to be this is the v naught is given, right? So it is going to be f square. So this is going to be will that mod f square, right? So minus will get, because it's a whole square is going, so it is going to be m square upon 2 get cancelled. Okay, for 2 times, this is m square upon 3 pi h cut square, this is v naught r cube whole square. This is going to be this. Okay, because 2 will get cancelled with this 2 times. Okay, so it is 2 m v naught, 2 m v naught, 2 m v naught. I'll write again this one. Not able to erase it. Okay, it got, and yeah. Now it's fine. Okay, so this is going to be, after solving, right, 2m v naught, 2m, because that whole square, right, f mod f square, so 2m v naught r cube upon 3 h cut square whole square. Okay, whole square. So this is the so now what we have done is we have changed v naught to 2v naught. In that case, uh, this d sigma 2, that differential cross section is going to be d sigma 2 upon d omega. This is going to be here. What we will do, in place of v naught, we'll write 2v naught, right? So it is going to be 2m 2v naught 2v naught r cube, r is fixed, okay, r cube upon 3 h cut square whole square, right? So it is going to be 2, this 4 will take common, so it is going to be 2m 2v naught 2m 2m v naught r cube upon 3 h cut square whole square, the same value, that is the d sigma 1 upon d omega, right, that is scattering amplitude, right? So this means this is going to be 4 this one, right? So this is 4 times d sigma 1 upon d omega, right? d omega. Okay, so which option is matching? Option number A, that is increases to 4 times the original value. So this is the original value, right? It's 4 times. Okay, so d sigma 2 upon d sigma 1, this d sigma 2 upon d omega, this is 4 times. Okay, 4 times. This is the answer. So option A is the correct option. Well, next question, that is question number 4, we are going to solve. A variational calculation. So I'll write the question number 4. A variational calculation, a variational calculation is done with the normalized with the normalized trial wave function psi x equal to root 15 upon 4a to the power 5 by 2 a square minus x square. This is the trial function, okay, for one dimensional potential well. For one dimensional potential well, that is Vx equal to 0, which is 0 if mod x less equal to a, okay, and infinite if mod x, the value of mod x greater equal to, sorry, mod x greater than a, okay. So this is given. So the ground state energy is estimated to be the ground state energy. Ground state energy is estimated to be okay. Option number A, 5 h cut square upon 3 ma square. 5 h cut square upon 3. Option B is 3 h cut square. 3 h cut square upon 2 ma square. 2 ma square. Option C is 3 h cut square. 3 h cut square upon 5 ma square. 5 ma square. And option D is 5 h cut square. 5 h cut square upon 4 ma square. 4 ma square. Okay. So this is the question. Question is a variational calculation is done with normalized trial function which is given. Okay. Root 15 upon a to the power 5 by 2 into a square minus x square for one dimensional potential. Okay. So one dimensional potential is given, right? So now the ground state energy is estimated to be. So you need to find out ground state energy. Okay. And trial wave function is given which is normalized. Okay. So we'll solve it now. So trial wave function is given, that is psi equal to root 15 upon 4 a to the power 5 by 2 a square minus x square, that is given. Okay. A square minus x square. And Vx equal to, that's also given, Vx equal to 0 if x mod x greater less than equal to a, and infinite if mod x greater than a. Okay, that's what is given. So we'll find out now the ground state energy with the help of trial wave function. So ground state energy is going to be integration minus a to a. Okay, that is psi h psi, this is psi star s psi dx, right? Where we know the value of Hamiltonian operator, right? That is minus h cut square upon 2m del square upon del x square. Okay, in 1D. Okay, so now we'll solve it. So it is ground state energy E is going to be integration minus a to a. We'll write the value. So this is going to be root 15 upon a to the power 4a to the power a square minus value of psi square is also psi star is also same upon 2m del square upon del x square into, this is again root 15 upon 4 a to the power 5 by 2 a square minus x square dx. Okay, very easy. Now we can easily integrate it. Now you just need to do integration. Okay, so it is going to be this one, right? Minus a to a, because potential energy is 0. Okay, a to a. Okay, first we'll multiply this constant. Okay, so this is going to be 15 upon 16 a to the power 5 integration minus a to a square minus x square, okay, minus h cut square upon 2m. Will differentiate it, so it is going to be dx. This is the value. So we will solve it further. So it is going to be, ground state energy is going to be 15 upon 16 a to the power 5 into minus h cut square upon 2m integration 2 also will take common, right? So minus minus going to be plus, and this is into 2, right? We'll write minus a to a, and this is going to be a square minus x square dx, okay? So ground state energy is going to be, okay, it is going to be 16 a to the power 5, okay, into 2 h cut square upon m, and this one, right? 2 h cut square upon m, and this will integrate it, so it is going to be a square x minus a cube by 3, okay, that is x cube by 3, sorry, x cube by 3, limit is going to be minus a to a, okay? So we'll solve it, so it is going to be 15 upon 16 a to the power 5, okay, this is 2m also here, okay, 2m 2 will get cancelled, into h cut square upon 2m, and this is going to be the value of this is going to be 4 e cube upon 3, okay, 4 e cube upon 3, 4 e cube upon 3, so this is going to be 5 h cut square upon 4ma square. This is the answer, okay, 5 h cut square. So ground state energy is 5 h cut square upon 4ma square, okay? So which option is matching? Let me check. Option number A. Sorry, option number D is matching. Option number D. Option number D. Okay, so this is the correct option. 5 h cut square upon 4ma square. Right, guys? Well, next question we are going to solve. Question number 5. Okay. This is also very good question actually. So question number 5 is a particle in one dimension. A particle in one dimension. In one dimension. A particle in one dimension is in potential if x less equal to 0, and minus v naught if x is between if x is between 0 to L, okay, and 0 if x is greater than L, okay. So this is the condition which is given. If there is at least one bound state, if there is at least one bound state, there is at least one bound state, if there is at least one bound state, the minimum depth of potential is, the minimum depth of potential is, okay, the minimum depth of potential is okay. Options are option number A, h cut square pi square upon 8 ml square. Option B is h cut square pi square upon 2 ml square. Option C is 2 h cut square pi square upon ml square, and option D is h cut square pi square upon ml square, okay. This is the question, guys, very important question. So the question is, a particle in one dimension is in potential is given, okay. Infinite if x less equal to 0, minus v naught if x is between 0 to L, and 0 if x greater equal to L, okay. So if there is at least one bound state, the minimum depth of potential is, okay, minimum depth of potential means you need to find out the value of v naught, okay. I'll draw the diagram so this will be clear to you. Then it will make it more clear. Let me draw the diagram, okay. This is straight line, guys. Actually, this is straight line, okay. This is straight line, okay, and this is the one, and this is, okay. So this is reason first, this is reason second, and this is reason third, okay. So this is the value between 0 to L, and this height is v naught, okay. This height is v naught, which you need to find out, okay. This height is v naught, and this is minus v naught, sorry, this is v naught, and this value is, this one is 0, okay. Their value is 0, okay. Yeah, so according to this condition, okay, x less than equal to 0, in that case this will be x is infinite, okay? This is infinite. Okay, so now we will solve it. So wave function for reason 1, so wave function for reason 1 is psi 1, for reason 2 is psi 2, and for reason 3 is psi 3, okay. So psi 1 is going to be 0, right? Psi 1 is going to be 0 because at infinite that is 0, because here p less than equal to 0, so psi is 0 at infinity, okay. Psi 1. Now psi 2, it is going to be a sine kx plus b cos kx. So here we take the reason, okay. So for a bound state, for a bound state, which is between minus v naught less equal to energy equal to 0. Okay, for this we are finding. So v naught minus v naught, for this bound state we are finding the value. Okay, this one. Okay, for so for okay. So here the value of k is going to be root two m this is because this is going to be e plus v naught, right? Because e is greater than v naught, right? So this is e minus v naught, means v naught is e minus vx, v, right? So v value is minus v naught, so minus minus plus upon h cut square. Okay. Now for wave function we'll find out. Wave function for region third, this region, for region third, this one here, v equal to 0. Okay. So this is going to be c e to the power minus gamma x. Okay, right? So this is the wave function for region third. Okay, now we will use boundary condition. Okay, yeah, c e to the power minus gamma. Okay, well, so now we'll use boundary condition, and we know the wave function is continuous at boundary condition, right? At boundaries. So it means the wave function is continuous at x equal to 0 and x equal to L, right? So we'll use those conditions. Okay, right? Wave function is continuous and differentiable at x equal to 0 and x equal to x equal to 0 and x equal to L. Okay, for this region, x equal to 0 and x equal to L. X equal to L. Okay, so here you should so if you will put values, right? If you will put values here, I'm going to tell you the trick as well, so it will be very easy for you to solve these type of questions. Okay, so if the wave functions, we have the wave function, and we know wave functions are continuous and differentiable at boundary condition, right? If we solve these wave functions at boundary condition, if we solve it at boundary condition, okay, using differential yeah, if we solve these wave functions at boundary condition, right, because these are continuous and differentiable, putting x equal to 0 and x equal to L, there is a condition, we find this value. Okay, this is eta equal to minus zeta cot zeta. Okay, very important, so you need to note it down. Then if you know this this expression, then you don't need to solve these wave functions at boundary condition and then find the value. Okay, so this is very important. And here the value of eta is kl, L is the length. Okay, kl, and value of
zeta is, value of eta is gamma L. Value of zeta is gamma L, and value of eta is gamma L, and value of zeta is KL. Okay, if you know this, then you don't need to solve any wave functions. Okay, uh, at boundary conditions. You just need to you can just, if you know this expression, you can directly proceed further. It will save your time. Okay, else you can put the value you can solve those wave functions, use the boundary conditions, right, and on these functions, and you will get the value. Finally, after solving, you are going to get this value. Okay, so now so we know this, so now we can easily find out eta square plus zeta square. Okay, so if you put the value here, because we know gamma, value of gamma square, right, so it is going to be gamma square L square plus K square L square, right, and we know the value of K is here, this one, and value of K is this, and value of, okay, here I haven't write the value of this, here value of here the value of gamma, this is also you need to write, this is root two m. Okay, it is minus e, because v is greater than v is less than this, right, e, so v minus e upon h square, this is the value. Okay, now we'll put this value here, we'll put this value, I will do it in next page. So this is going to be eta square plus zeta square. Okay, this is going to be this value is going to be this one. The value of gamma is this one. Root 2m root minus, sorry, 2m minus e. Okay, 2m minus e upon h square whole square L square, and value of e is root 2m e plus v naught upon h square whole square. Okay, this is the one, and if you solve it, zeta square, it is going to be 2m v naught L square upon h square. Okay, so also in question this is given for one bound state, right? Question is also given if there is at least one bound state. Okay, in question it's given if there is at least one bound state. For one bound state, we know the value of eta square plus zeta square is going to be pi by 2 for one, at least one, for one bound state. Okay, okay, this value is going to be pi by 2, that implies, and value of eta square plus zeta square, we know 2m v naught L square, 2m v naught L square, L square upon h cut square is going to be pi by 2. This implies value of V naught. Value of V naught is pi square h cut square, pi square h cut square, okay, upon 8 ml square, okay. Okay, so it means to the power 1 by 2 equal to pi by 2, okay. So this is the correct one. Zeta square is this. So root zeta square plus this is pi by 2, okay. So we will solve it, and then this is going to be, this is the answer, guys, okay. Okay, so this is the one. Let me just check the time. Okay, we are going to solve one more question actually. This is question number 6. This is easy one, so I'm going to solve it for you as well. So this is which of the following, question number 6, which of the following is a self-adjoint operator? Following is a self-adjoint operator. Which of the following is a self-adjoint operator in the spherical polar coordinate? In the spherical polar coordinate. Polar coordinate system, okay. Polar coordinate system. Polar coordinate system, that is r comma theta comma phi, okay. Options are given. Option number A, minus I h cut sin square theta del over del theta, okay. Option B is minus I h cut del over del theta. Option C is minus I h cut upon sin theta del over del theta. And option D is minus I h cut sin theta del upon del theta, okay. So this is the one. So which of the following is a self-adjoint operator in the spherical polar coordinate system, okay. So you need to find out the operator, okay, which is self-adjoint, okay, in spherical polar coordinate. So this is the correct answer. This is option C, because I h cut sin theta into del over del theta, right? Because if you check it, that so you will find that this operator is Hermitian operator, okay. If it is Hermitian operator, it means that is self-adjoint, okay. So you can check it, and this option is correct. So it's easy to check, right? Like we know, if psi a psi, this is function, right? We have, if we, for checking any operator, if it is Hermitian, so it will be like a psi psi, okay. And if it is giving like value like this, minus a psi psi, in that case, it's not Hermitian, Okay, it is Hermitian. Okay, you can check it by this. So this operator is Hermitian and this operator is self-adjoint in spherical polar coordinate, guys. Okay guys, so I will stop here, and thank you so much for watching my lecture, and I would request everyone who haven't subscribed my channel, please subscribe my channel and watch my lectures, which are very important lectures, right? And my courses are going to help you to crack any examination related to physical science. Okay, so okay guys, so thank you so much. Bye now.